Okay, let's get started on adding fractions. Just want to start out with the first process rule. The main rule that we know for fractions when we're adding or subtracting is that if the denominators have to be the same. You cannot either add or subtract fractions if you have different denominators. So the only rule we have to really remember is after you get the common denominator, you just either add or subtract the numerators, and only the numerators. The denominator will always be the same. What it is in the problem, it will be in the answer. So in this case here, we have 1/3 plus 2/3. What should our denominator be? 3. And our numerator is going to be 1 plus 2, or 3 over 3, which equals 1. Last step is we always simplify. Have a common denominator as we had here. We got to find the common denominator. Let's do a couple of examples of that. Let me take this down. Let's say I got 1/5 plus 3/10. Can I add those two together? No. All right, so what do I have to do? Find the common denominator. Well, 5 goes into 10, right? So I know I could change fifths to 10. So let's take this 1/5 and change it to tenths. Well, I had to multiply the denominator by 2, so I have to multiply the numerator by 2. 1 times 2 is 2, so 2/10. So what I'm going to do is I'm going to replace 1/5 with 2/10. So this equals 2/10 plus 3 over 10 equals. Now, denominator is always the same, right? Add the numerator. 2 plus 3 is 5. And the last step?
1/2.
1/2. Divide both numerator and denominator by 5. We're going to get 1 over 2. That's our final answer. This time we've got 2/3 plus 1/7. Can we add those together? No. All right. What would our common denominator be? All right, so we're going to change 2/3 to 21sts, and then we've got to change 1/7 to 21sts. What do we have to multiply the 3 by to get to 21? 7. So if we do it to the denominator, we have to also do it to the numerator. 2 times 7 is 14. So the 2/3 changes to 14 over 21. Right, so this actually goes to there. And what do we have to do to the 1/7? Multiply by 3. And we're going to get 3 over 21. So the 1/7 changes to 3 over 21. That goes to there. All right, so now we got to add. What's the first thing we should do? Yeah, move the denominator up because we already know it's the same, right? 21. Now, 14 plus 3? 17. So 17 over 21. If 2/3 plus 1/7 is going to be 17 over 21. Now, the next question we got to say, is this in simplest form?
No.
Is there some number that will go in both of these?
No.
No. 17 is a prime number, so as long as 17 doesn't go into 21, this is in its simplest form. I'm getting there.
Question. Try to understand what we got first.
9. 12.
All right. All right, your common denominator here is 12ths, right? Because 3 goes into 12, 6 goes into 12. So let's change 1/3 to 12ths, and let's change 2/6 to 12ths. All right, 3 goes into 12 4 times, so we have to multiply the 1 by 4, so it's 4 over 12. And over here, what do we have to multiply the 6 by to get to 12? 2. So we got to multiply the numerator by 2 as well. 2 times 2 is 4. This is 4/12 again. And we're going to add 1/12 to that. What's our denominator going to be? 12. And what's our numerator? Yeah, 4, 8, 9. Now, I'm going to just bring this over here. Well, what's divisible into both of these? 3. we have 7/8, and we're going to subtract from that 1/4. Fourths meaning fours. For those of you who can't read my writing. Do we have a common denominator?
8.
Well, I was saying, do we have it?
No.
The common denominator is 8. You're going to step 2 before we go to step 1. So let's change fourths to eighths. So what do we have to multiply this 4 by to get to this 8?
2.
Do it to the denominator, we have to do it to the numerator, it's 2/8. So let's rewrite this problem. Minus 2/8. We're going to get eighths here. 7 minus 2 is 5, so we got 5/8. Is it in the simplest form? Yes, it is.
Yeah.
3/4 minus 3/24. Do we have a common denominator?
No.
No. What is our common denominator? 24. Because we changed fourths to 24, so 3/4 goes into 24. How many times does 4 go into 24? 6. So let's multiply this by 6. Let's multiply the numerator by 6. 3 times 6 is 18. So let's rewrite this equation. It's going to be 18/24 minus 3/24 equals, our answer is going to be in 24.
15, 24. Oh,
Now, 18 minus 3 is?
15.
Okay. Now, the question I'm going to ask you, is there any number that's divisible into both?
Yeah.
Numerator and denominator?
3.
3. All right, let me move this over here. 15/24 divided by 3 divided by 3 equals 5/8. Is there any number that is divisible into both 5 and 8? No. So that's in its simplest form. Let's start out easy. Let's say we have 3 1/2 plus 1 1/4. There's 2 methods we could do this. I'm going to call this method 1. We could change this to 3 plus 1. That handles the whole number portion. And then we could do the fractional portion. So that's 2 steps. All right, so the answer here is going to be, this is going to go to 4, right? But we still didn't resolve the fractional part. What's the problem here?
They're not common. That means they're not the same.
Yeah, so we got to change 1/2 to fourths, right? So what do we have to multiply the 2 by? So we're going to have to change this to 2/4 plus 1/4. Now it's going to be 4 3/4. Now be advised, sometimes this may go over 1. You're going to have to add 1 to here and then have a fraction also, right? It may be, it's possible for this to turn improper. Then you're going to have to change it back to a mixed number. And then you're going to have to add whatever, the whole number from the improper fraction back to the whole number here. All right, I'll do an example of that later.
Okay.
Yeah,
Just,
please.
it's coming. But we're going to make it improper over here. So let's change this to 3. Okay. And let's see, this over here is 3/4, right? This becomes 3/4.
All right.
All right, so what I changed is this and this. Right, because I just changed this from 1 to 3. So now, here's the 2 changes now. So I'll give you a minute to copy that down. All right. We already added the 3 and 1 got 4. That doesn't change. We got to add this together, right? This is going to become what? 4, and this is going to be 5/4. That's saying that this fraction is greater than 1. So we have to take the 1 from this and put it back over here. So 5/4 is going to change to what? 1 1/4. Everybody follow me on that? If you convert this to a mixed number, what are you going to get? 1 1/4. All right, because 5 over 4 is equal to 1 1/4. Yeah, you change this improper fraction, you turn it back to a mixed number. Now, I got to add the 4 and the 1 together. So now I'm going to get 5 and 1/4 as my final answer.
How did you change that back to a mixed number?
Division.
I had 5 over 4, right? I divided 4 into 5. 4 goes into 5 once. So this is 4 minus, I'm going to get 1. This becomes the whole number. This becomes my numerator. This becomes my denominator. That's how I get the 1 1/4.
Explain the next part now.
All right, I got to add, since I have a whole 1 here, I have to add 4 and 1. So I put a plus sign there. 4 plus 1, that's 5. Fraction stays the same.
And that's how you do it if it becomes an improper fraction?
Yes. When we're subtracting fractions or mixed numbers, it's easier to do it vertically.
Oh,
Okay. We could have no problem subtracting 2 from 5, right? That's the easy part. But look over here. Got a little problem here.
Oh, yeah.
We got 1/4 and we're trying to subtract 3/4 from 1/4. Can't do it. Here's what we're going to do. We're going to borrow 1 from here. Let me get it.
Oh, no.
We're going to change this 5 to 4 and 4/4. Isn't that the same as 5?
Is this the first method?
Oh,
Yeah, this is another one.
Oh, method 1. Oh, sorry.
Same as 5, but it's not 5 and 1/4.
What?
Isn't this the same as that? You got 4, and 4 over 4 is 1, so 4 and 1 is 5. Now we got to add the fractional portion.
So why wouldn't you just put,
This goes to 4 and 5/4, right? And we're going to subtract from that 2 and 3/4. Now we can take 3 from 5, right? Because we know our denominator is going to be in fourths. So this is 5 minus 3 is 2, and 4 minus 2 is 2. So we get 2 and 2/4.
I got it.
You got to do it? All right. This is going to equal 2 and 1/2. Because we're going to divide both of these by 2 and get 1/2. Minus 3 and 7/15. Okay? So I had to change this to 15ths. That's what I'm going to get.
You do 7 times 15 plus 3.
Yes. All right, so now let's do that. We're going to change it to an improper fraction, so it's going to be, still going to be, both of these are going to stay in 15ths. So it's going to be 7 times 15 plus 3, and this one's going to be 3 times 15 plus 7.
Let's finish it.
All right, 7 times 15,
105.
plus 3,
108. That's what I can.
108, minus 3 times 15, 45, plus 7, 52.
And he gets 56 over 15.
And we subtract this away, what are we going to get?
56 over 15.
56 over 15.
Well, no, you can't reduce it unless you change it.
Yeah, you can't reduce it.